Thank you all for being here. I'm Charles Paul. I'm going to talk about geometry. And so what I will try to do today is just to kind of give you a view of geometry, what we kind of envision in long term, as well as kind of a brief stature of where things are. Right? We have a lot of functionality in geometry. And I kind of want to group them and give you the perspective and kind of, I hope in the next coming release, you kind of see, where we are going, how the new functionality fit in our vision in general. Okay, so one first thing when you have, when you want to use geometry in the system, right, you need to build it, or you need to bring geometry to the system, right? So right now, we just talk about the multi-paradigm modeling. So just that aspect, right? And after that, there is the visualization, right? Usually, 3D object or 2D object, you want to actually see them, right? So what do we have in terms of that and where we are going? And the last aspect, obviously, is the computation, is what I call computational geometry, right? So you'll see how everything fits, all together in that framework, right? And well, in general, there is, all additional verticals and related things, which I will not talk about today, but, maybe next conference, we'll see where we are in terms of that. So before I start to talk about modeling and the general view of modeling, I'll first, talk about, how to bring geometry or how to get access to geometry in the system, right? If I just give you a mathematical in a blank notebook, right, and you want to play with geometry, what will you do, right? So one first easy way is to first, get geometry from a, file format or from another system. So what we did, we have, we try to support about, a dozen file format, most of the standard one, and we hope to continue to actually extend that and go more to the direction of CAD system and enhance those connectivity, right? So in this case, this is 3ds, right? So we kind of import it. So right now it's purely the geometry, right? So that's kind of the statue. We are not yet handling texture or any other additional decoration you have around the geometry. But it's kind of the direction where we are going slowly and adding all those support. So to kind of preserve the fidelity when you import your file and get everything back. So that's in terms of importing. But also what we try to do is to allow you to use the curated data and the geometry behind it, right? So in this case, if you take, for example, our nice anatomy data, right? You have, body part and such, you can actually get geometry out of it. So if you just evaluate that, you ask, what is the skull? And you say, I want the mesh region. It will generate you that. And it's a nice mesh region. All nicely curated, and it just works, right? And the same apply for the mathematical one, not data, polyhedron data, chemistry and such, right? So, and actually all entity, as you see here. So if you have an entity and you can check if it have a polygon or a mesh region, and then you can just call it and then you get the geometry. And now you can play with it, right? If you just want to do 3D printing, you can just take this and send it to your 3D printer and you get the actual skull. The other work, which actually is new in this release, is we are migrating example data and adding more collection, more geometric object into the Wolfram data repository. So that's the general direction now where we put all data. And we are, we started to first collect, all the standard geometric model, what people use to kind of benchmark algorithm and such. So they are now available in the resource Wolfram data repository. So in this case, if I evaluate the Stanford Dragon, for example, there you get the nice Stanford Dragon. You can rotate it, see everything. So it's a large mesh about the million polygon and everything is work nicely, right? And you can actually run this command I have at the bottom there, sorry. You'll actually call the repository and kind of give you the list of objects we have there. Well, it's taking a lot of some time here, but there's a collection of objects we have right now. These are not all the objects. I just checked the one which are tagged with geometry. Right? But we hope as we continue to actually add more models there in the data repository, and you can just call it and get geometry. Okay, so in short, you can import data, we have curated data, and we have more data in the repository, right? So that's kind of one way to actually bring geometry to the system, okay? So now if you are more, geometry inclined and decide to do actually modeling and actually build the model from scratch, you can take the one in the repository and transform it, or you can just use, one of the different, modeling techniques we have. So the first one we have is, what we call primitive extension. So what we did actually when we were designing geometry is that we tried to keep it close to our graphics. So we preserve the graphic primitive, right? So I don't remember when ball was introduced in the language, but the same ball, symbolic expression, you can use it in geometry. So we didn't create a new object. And we hope in long term that all the graphic primitive will be actually geometric object, right? And one project also hopefully we'll do very soon will be actually to add to the system spline. So you can take your Bezier curve, your spline surface, and there'll be geometric objects. So there is that whole framework we are starting to work on. So that was about geometric extension. And later on, I will talk about this object region, which is a wrapper, which allow auto visualization, right? Well, I will talk about it actually right now. This is quite a powerful object, which we haven't promoted enough, right? Because like in this case, you have a ball, right? The ball doesn't have any unit or any additional information. So what we hope is that the region wrapper here will be the wrapper will kind of carry that meta information. So you'll be able to actually have a unit for ball. And if you decide to print your ball in a 3D printer, you have the right size you have, right? The same as you can take the ball and actually style it. Actually, I should do that here. That's actually next object example later. So the region object, you can do, for example, style. Oops. There we go. Backs off. So the region, and then I do a red. And then I get a red ball, okay? So we carry that, visual information behind with the region wrapper, where you cannot actually attach that object to the ball. That primitive is already taken. There's no option for that, okay? So the same for implicit region. So in this case, it's just a, a sample circle. So if you want to do, you're more mathematically inclined, you can just describe your region as a, an algebraic equation or such, and then you can just use implicit region. We also have parametric region to describe your implicit region that way. And the last one is mesh region. So I think most of you here actually kind of know already that, so there's pretty much nothing new there. But what I want to emphasize is actually that part where we are going. So we have primitive extension where we essentially extend all the primitive we have. We have implicit representation. So we have implicit region, parametric region, and then we have mesh, which is a whole subsystem. And the next one will be probably spline. But before we jump in spline, in the last version, we actually introduced constructive solid geometry or CSG regions, right? So if you are more in that, well, I won't say subtractive manufacturing, but where essentially where you want, constructive solid geometry essentially mean you start with basic primitive and then you remove parts or add parts. So there's that, subtractive additive manufacturing type techniques, right? So it's what kind of allow you to actually build object of that type. So in this case, you can, for example, easily build this 3D shape by just taking a sphere and then you subtract cylinders. Right? So that's kind of pretty much the idea. So what we try to provide is all those different techniques. So if you are more comfortable with a certain type of technique, then you just use it. So that's kind of our idea where we are going with geometry. And this is kind of a more complex object. So the different parts you see in engineering are more usually built from that constructive solid geometry. Okay. And I think this was added in 13.1, last year. So the plan is continue to add different techniques right? And as we add those different techniques, we're going to start to, go more vertically. So if you add, for example, a spline, you probably will add connection to CAD system, right? So it can be in your favorite CAD system, use whatever you have there, come back to the Wolfram language, take advantage of what you have there, or push back and forth. That's kind of the big vision we have. And the last part, which is more also just to stay in the language, is that we are going to build more bridges to different parts of the language, right? So in this case, I kind of just show what we have there, we have right now. So with image mesh, you can, for example, take an image, a 2D or 3D image, and just call image mesh, and you get your geometric object, right? So there is your object there. So that's, behind the scene, we just run a classical mashing cube to get that. You can also take your graphic object and discretize it, and then you get the geometry associated to it, right? And later on, we also add more techniques to actually discretize with preserving the right fidelity. So discretized region convert it to a mesh, but you can also describe this object as a union of two, a disk and a cylinder. So we'll add probably more function like that where we preserve those structural information of your geometry. And the last one we have been working, hard behind the scene, but naturally work is graphy. So in this case, you can take a polygon of a country, in this case is France, and you just discretize it, and then you get actually your region here, right? So this is on the sphere, right? So, and if you get a grid geoposition, that's kind of geometry on the map. So we project it in 2D. So geoposition will give you in 3D, and grid grid position gives you something on the map. That's pretty much the two approach. And then we preserve the fidelity. So we don't get your country and apply it on a projection on the map in 2D. And this object, you can take it, compute the area there, will preserve exact or give you approximately the right, area of France and such. So that's kind of in terms of part of the integration deeply in the system and such. So this integration is more, right? We move from geometry to image, and you can also go from image to geometry, right? And we also have integration in terms of operation. You can do a plot on a region. You can optimize over a region. You can solve over a region. So there's also that whole compute framework, which is, behind the scene and just work naturally, right? Because, geometry, one of the advantages of geometry is that it's a language. You can express a lot of things geometrically, right? And so we kind of try to push it in the system behind the scene and just say, I want to plot my function over a disk, and it'll be plot over a disk. I already kind of talk about visualization a little bit with the region object, but I will just show you a little bit what we have right now. So most of the directive and all the feature we are adding now, like the physically based rendering and such in graphics, you can actually use that in region 2. And it's kind of also one of the drivers for the new functionality in graphics. So in this case, I just take the ball I have there before and I say, okay, I want a physically based rendering. I want the ball to look like an actual ball, which should like iron. So I will just do that. So that's the ball. Right, I need to adjust the light. So I will say lighting. Go to 3-point light. Right. So you have your geometric region here, which is the ball. You can still compute on it and it looks realistic, right? So our goal is that, if you have a chair, right, it have the right geometry, you'll have the right texture, the right look, but you can still compute on it. So we kind of intersect with graphics, get the right quality graphic and the right computation on top. And this is actually a new version in the coming release of 13.2, right? In that direction of adding, getting more realistic object, we added support for Vertex Color and Vertex Normal to mesh region and boundary mesh region. So this is an example of a scan object. right, where you actually have a Vertex Color directly applied to it, and you can still compute on it. So here, if I evaluate that and I check, this is a mesh region. And just to prove you that that's correct, so if I turn off the Vertex Color, which strangely, I think I'm on the wrong build. Shall we continue? But if you turn off the Vertex Color, you get the, the mesh without the geometry here. Well, I will check that later on what's happening here. I'm probably on the wrong build, but that's okay. Right. But in principle, we just remove the Vertex Color and you just get the base geometry pretty much there. Okay. With a few minutes left, I will just go and a little bit talk about the computational side and where we are going. So one of the new features we added in the last release and more enhancement actually in this coming release will be the region reconstruction. Right. So earlier version, we have gradient fitted mesh, we have region fitting, a collection of sub-functions to actually, pretty much approximate the geometric object you have. So we introduce reconstruction mesh to kind of do that whole automation for you. You just generate a bunch of points and we magically look at it and say, well, it looks like a curve, and we build you the right object. So you don't have to know that you need to use gradient fitted mesh because it's probably of dimension 2 and then the Laplacian or something match and such. So we do the whole automation for you behind the scene. So in this case, I just kind of select point from a Stanford bunny. So if you look at that, you just have a point cloud here, right? And if I evaluate it through reconstruction mesh, so it's running reconstruction there, and then you have the Stanford bunny there. And in this case, it actually returns you a solid object. So it's a boundary mesh, which is actually closed. So reconstruction mesh is that general function you should use now, which kind of automates all the reconstruction functions. And if you want to go more deeper, then use gradient fitted mesh because you know exactly the mesh method and the technique behind, or concave hole mesh and such. And obviously, one of the last features we added is Veronite 3D. So right now, you can actually just Veronite mesh and generate it. And this is just the styling behind the scene. And then you get the Veronite cell there. So in long term, we are going to continue to add more functionality in terms of, computational geometry, right? And also, if you really think about it, right? So we have general function, which usually start with region. Well, that's not really correct. You have, area, perimeter, and such, which are all general function working on top of regions. But for those set of functions, right, they work on region. So mesh, region, line, point, they all work on those, right? But we also have now subsystem. So for example, mesh, we have a whole subsystem of function. We start with mesh, like mesh vertex count, mesh cell style, and such, right? And we'll do exactly the same, probably for, when we go to spline. We are going to have a spline object, right? And all your functionality will work on spline, but you have a bunch of sub-function, a subsystem which actually manipulates spline, right? So just keep that in mind. So we have a set of functions work on all region, and a subset which work on that subset, so mesh or spline. And that's pretty much it, what I wanted to talk today. So I hope you kind of got a clear idea where we are going. And in the next coming version, we see more and more functionality, more and more stuff specialized on spline and such. And I will invite you to stay around and listen to Alec talking about reconstruction just after me. Oh, just an hour after me. Jebon will talk now about progress in graph and networks. Right. And we have office tomorrow morning. So if you have questions about geometry, please stop by, as well as question about graph in the afternoon tomorrow. And we have our live stream. We always give every Wednesday, from Wolfram R&D. So you have the link there, and it's also kind of it's advertising community. So we are there. Don't hesitate to come and watch. And if you have questions, that's kind of a easy channel for you to ask questions and get in touch with us. So thank you. Polygon with holes. I'll do my best to answer that, otherwise usually there. So we added polygon with holes, so you can actually so we have our old function, the old standard polygon, which is just list of points. So there's also polygon with holes where you can actually specify the holes as the second argument of the role. So the first part is the coordinate of the outer boundary, and the holes are essentially the right-hand side. And let me show you if there is hopefully an example here, if I'm lucky. Well, I'm not lucky. Right, that should be right, probably the right one. I think I'm using 13.1. Okay, so this is an example, thanks Jibom, of where you have a polygon here, so you have the list of. So this uses the graphic complex syntax. So you have the list of coordinates here, and then this is the outer polygon, so the one around. And the holes essentially is that and specified by the hole. And you can use outer polygon to get the outer polygon, inner polygon to get the inner part of the whole thing. And it behaves like a normal polygon. And in the same direction, if you want to go more deeper in the outer and inner, we have also wanding polygon, where you can actually define the type of definition of polygon when there is a self-intersection in your polygon. Okay. Any other question? Yes, please. Circular arrow. So you just want a circle with an arrow at the end, a arrowhead. Right, so you can actually, generate an arrow, a circle, and or a line, a list of point line, and just say arrowhead, and you will actually add the arrowhead. So on that, right, so you want a complete curve. Oh, right. So in this case, you probably have to construct it from a B-spline, right? So to construct a circle from a B-spline, I probably need four splines, right? Oh, so you want to get the control point for your B from a circle. I don't think we have such a function, but there was an example. I can show that later. There's an example somewhere in the documentation where essentially you have a circle and then you get the control point for your B-spline. But the easiest way, you just, the circle is 4 patches of B-spline, so you just create the 4 patches. Right. One last question.
I just have a question about.
Right now, automatically, no. So first, we don't support, spline is not yet a region, right? So I will say, so in long term, we hope that will be a region. So in this case, you probably need to discretize your spline. So you get an approximation and then run the appropriate operation on that. Okay, well, thank you very much.